Okay, let's go over the test we just took. So we have time and the velocity at these times. And we're supposed to find out A is the acceleration, B is the velocity, and T, the object decelerates and its velocities are given in the table. So, it's not decelerating, it's accelerating. The velocities are increasing, so that's a typo. Accelerates. And the velocities are in meters per second. And we're supposed to find R6. And this is another typo. It's supposed to be going up by 2, so this was supposed to be 13. So 2 typos in the first question. Not a good way to start. Okay, but anyway, write 6. So if I go from 1 to 3, that's a column, and 3 to 5, and 5 to 7, and 7 to 9, and 9 to 11, and 11 to 13. That's 1, 2, 3, 4, 5, 6 columns. And that gets me all the way over. And if I'm doing the right side, 1, it's at 2, at 3, it's at a height of 4. The right side is at a height of 4. The width of the column is 2. The width of all these columns, as long as that's 13, is 2. And the height of the right side of this one is 4. The right side of this one is 8. The right side of this one is 14. The right side of this one is 16 and 20. Excuse me. And 22. I apologize. Oh, all right. We've got to get this taken care of. Okay. 4 and 16 is 20, 40, 62, 70, 84 times the width. And that's 168. And the width is in seconds. And these heights are the velocity, which are in meters per second. So seconds times meters per second, the seconds cancel, and we get the distance it changes is 168 meters. Now, if we do left 6, we're going to do the same columns, but only use the left side instead of the right side. They're still too wide, and the left side of this one has a height of 2, and then a 4 for this one, left side. This one, left side, is 8. Left side of this one is 14. Left side of this one is 16. And the left side of the last one, the sixth one, is 20. Now, the other way you could have gotten this number would be to take the end minus the beginning over how many columns? 6. So that's 12 divided by 6, which is 2. Some people did it that way. They just want to show you how you do that. All right. 2 plus 8 is 10, 14, and 14 is 28, 48, 58, 64. Times 2 is 128, and again, it's going to be meters. Since this is increasing, the left side on the graph, or the right side on the graph, will be over estimates, right side, the right side. And so we'd be getting over. And if we did left side on the graph, I'd be getting under estimate. So what if we did midpoint 3? So we got to do 3 columns, or yeah, 3 total columns. So if I go from here to here as 1 column, and those 2 together as 1 column, and those 2 together as 1 column, and I find the midpoint of each of those, the height at the midpoint, times the width. Well, the width goes from 1 to 5, so that's 4. Or you could do 13 minus 1 divided by 3. 12 divided by 3 is 4. And the height, the velocity is the height at not 1 or 5, but at the middle is 4. And on this one, it goes from the 8 to the 16, but the middle, it's at 14. And notice we're not using the averages. That would be trapezoid 3. We're doing the height at the middle. The height at the middle, 4. Height at the middle, 14. Height at the middle, 20. So 18 plus 20 is 38. Which is 120 plus 32 is 152. And midpoint should be closer than either the left or right hand, usually. So it should be somewhere between them, and it is. All right. Now, the trapezoid 6 means we want to use the average of the left and right. So the width of a bar, if we're doing 6, there's 2 each between each. So the width of the bar is 2, just like it was here or there. And we don't want to use 2 or 4, but halfway between. Well, that's 3. You could go 2 plus 4 is 6, divided by 2 is 3. 4 plus 8 is 12, and half is 6. 8 plus 14 is 22, and a half is 11. 14 and 16 is 30, and half is 15. 16 and 20 is 36, and half is 18. And 20 plus 22 is 42, half is 21. Or 21 is halfway between 20 and 22. And this would be the trapezoid. And 3 and 6 is 9, plus 11 is 20, 35, 40, 35, 45, 53, 54, 74. Which is 148. Now we could also do the average of, if we're doing trapezoid 6, we have to do right 6 and left 6 average. So that'd be 168 plus 128 divided by 2. This is 16 and 12 is 28, and 16 is 28, 280, 296 divided by 2, which is 1, 4, and 16, 8. Same answer. So you could do this, you could do this, or you could do width of 2, get half of the first, height is be 1, plus the ones in between, 4 plus 8 plus 14 plus 16 plus 20 plus half of the last, So that's 5 and 8, 13 and 14 is 27, 33, 43, 63, 64, 74. Same number as we had for here. 74 times the 2 is 148. 3 ways to do the trapezoid. Okay, problem 2. Determine the value of an overestimate, either right 4 or left 4, on the interval 1 to 3. From 1 to 3, and when we want to be an overestimate, and we want to do 4 bars, so it looks like each bar would be 0.5 wide. And if I want to do an over, I'm going to go to the left side and do a bar. And then I'm going to go to the left side and do a bar. And then I'm going to go to the left side and do a bar. And then the left side and do a bar. So each one is a half wide. The height of the first one is just shy of 6. I'll cut 5.8. The second bar is not 3, not 4, maybe 3.5. The next one looks like it's about 1. And the last one looks like it's about 0.3. So 5.8 plus 3.5, that's 8, 9.3, 10.3, 10.6 times 0.5, which means take half of that, which would be 5.3, is a reasonable answer. Something around that. Now, why is the left an overestimate? Well, it's going to be an overestimate because the graph is decreasing, so the left side is always higher than the right side. Decreasing. So left side is always higher. Okay, page 2. Page 2 is dealing with snow on a patio. Not ice as in the sample test, and not on the ground. It's on the patio. Okay, I wasn't picky, but you should be using the right vocabulary for the scenario. Okay, so this means at 5 hours after 12, so 5 p.m., there's 6 inches of snow. At 3 p.m., there's 2 inches of snow. At 9 p.m., there's 12 inches of snow. Between 7 and 9, there was 2 more inches of snow. Between 1:30 and 5 p.m., there was 4.5 more inches of snow. And this says, so how much snow was there at 7 p.m.? Well, from 7 to 9, it went up 2. And at 9, it was 12. So going back, 7 must have had 10 inches. So it's 12 minus 2, or 10 inches of snow at 7 p.m. Now it says, how much did the snow increase between 3 p.m. and 7 p.m.? Well, 3 p.m. it had 2, 7 it has 10, so it increased. Doing the integral, you're finding the change. It increased by 8 inches of snow between 3 p.m. and 7 p.m. Okay. C. How much snow was there at 1:30? Well, from 1:30 to 5, it went up 4.5 inches. And at 5, it was 6. So if we go backwards, remove the 4.5 to get what it was at 1:30, we'd have 1.5 inches. 6 minus 4.5 is 1.5 inches of, come on in, snow at 1:30 p.m. And the last one, from 5 to 7. From 5, it was 6 inches. At 7, we figured out 10 inches, so it went up 4 inches from 5 to 7 in the 2 hours. So it was 2 inches per hour increase, average increase of snow. 2 inches per hour is the average increase of the snow between 5 p.m. and 7 p.m. Number 6. Okay, so we have to find the area under this. And so this is x to the minus 1, which is another name for 1 over x. Can you use the power rule? Well, if you add 1, you get 0. And then you have to divide by 0, but you can't divide by 0. So this is the one exception. And the antiderivative of 1 over x is ln, absolute value of x. Antiderivative of cosine is sine. Derivative of sine is cosine, not negative, so we have to do negative sine. And we got to evaluate from 1 to 3, so we put 3 in, and we get ln absolute value of 3, but absolute value of 3 is 3, so I'll make that simple, and then put in 3 in here, and I get minus sine of 3 minus ln, putting in the 1, absolute value of 1 is 1, minus sine of 1. And ln of 3 is an ugly number, sine of 3 is an ugly number, ln of 1 is 0, and sine of 1 is an ugly number. So this could be, you could leave it just like this, or you could write it ln 3 minus sine 3 minus a minus plus sine of 1. And you can't combine those easily. So I would just leave it like that. Absolute value. You should ignore the absolute value and figure out what this graph looks like. Well, that's a minus x squared, so it's an upside down parabola that's moved up 1. So it's going to go through 1, and then it's going to go through 1 on the x-axis and minus 1 on the x-axis, and it's going to look like this. And if we're supposed to find the area between 0 and 3, some of the area is positive and some of the area between the curve and the x-axis is negative. Always go to the x-axis. So we need to figure out, we want, the absolute value says make all these areas positive. So we want to do the integral from 0 to 1 of this equation, which is 1 minus x squared. Figure out that area, and it should be a positive answer if we work this out. And then we got to figure out the area from 1 to 3 under this curve, or between the curve and the x-axis. So I shouldn't say under the curve. That area answer should be negative, and we should have to change the sign of that to make it positive. So I have to put a negative on there. Let's just check that. So antiderivative of 1 is x. Antiderivative of x squared is x to the third over 3. Evaluated from 0 to 1. Put 1 in here, we get 1 minus 1/3, which is 2/3. Positive area, that's what this area is. And if you put in 0, you get 0, so that's why I stopped doing it. Now for this one, it's still that same thing, x minus x to the third over 3, evaluated from 1 to 3. That area should be negative, and we have to change the sign. So if we put 3 in there, we get 3 minus 27 over 3, or 3 minus 9, or minus 6. We put 1 in there, and we get a 1 minus 1/3, which is 2/3. So this is minus 6 and 2/3. That's this area. And we have to take the negative of that because it says absolute value of these areas. So this becomes a positive. So we got 2/3 plus 6 and 2/3, which is 7 and 1/3 for the area, exactly. And you could have left it like that. For the last one here, these are backwards. So if I switch them, then I put a negative. I don't put a negative because they're backwards. If I switch them to forwards, 2 to 5, then I put a negative. So if I don't want to switch them, I can just do the antiderivative of e to the x, which is e to the x. Antiderivative of a number is that number times x. Evaluated from 5 to 2. So I put in the 2, and I get e to the 2 minus 2 times pi, minus, put in the 5, and I get e to the 5 minus 5 times pi. And I can leave it like that, or minus 2 pi plus 5 pi would be 3 pi, and e to the second minus e to the fifth can't be simplified, so you could factor out an e squared out of both of those and have e squared times 1 minus e to the third if you want to do that, but that's good enough. This was good enough. So capital F is the antiderivative of little f, and so the antiderivative of 2t is 2t to the second over 2, 2's cancel, minus 3t, one more power, 3 over 3, that new power, those cancel. So it's t squared minus t cubed plus something is going to be capital F of t. And capital F of 2. So if I put 2 in for the t's, I get 4 minus 8 plus c. I'm supposed to get minus 2. Well, if c wasn't there, I'd have minus 4. Minus 4 plus 2 would make minus 2. So c has to be plus 2. So my equation, the antiderivative of this, is going to be t squared minus t cubed plus 2. Here, this is a velocity graph in meters per second. We're supposed to go up to 16, which is here. And it looks like we got more positive than negative, so it's going to go to the right. And we just have to figure out how much more area is here than here. Well, this will cancel this because they both go to about 15. Negative 15 and positive 15 and 5 and 5. So these areas will cancel. So all I have to do is figure this area. This is 6 and this is 6. 6 times 6 is 36 for this rectangle. But we have to add this triangle, which is 9. 6 to 15 is 9 by 6. And if that's going to be 54 in half 27. So it's going to be 27. This is in seconds, and this is in meters per second. So the seconds are going to cancel, and so it's going to be 27 meters, more positive than negative, to right. Now the total distance, that's going to be this area, which was the 27 plus 36 is 50, 63. Oh man, don't make the mistakes like that. 63 to the right. So it's going to be 63 plus whatever this is, plus whatever this is. Well, this is 5. This is 15. So 5 times 15 is 75 in half. 37.5. This one's negative. This is also 5 by 15, so this is 37.5. But when we do distance, we don't keep track of negative. We just keep the area. So that's these two together is 75, and these were 63. Adds up to be 138 meters. All right, 9. Put minus 1, we got 1 minus a minus 1 plus a minus 1 squared. So that's 1 plus 1 plus 1, 3. For I equal 1, minus 1. Then we got to do I equals 0. So that's 1 minus 0 minus plus 0, which is 1. And then we got to do I equal 1, positive 1. So that's 1 minus 1, 0, plus 1 squared, which is 1. So we have 3 plus 1 plus 1. And then we have to do I equal 2. So 1 minus 2 is minus 1. And 2 squared is 4, so that makes this be 3. And then we have to do I equal 3, and I equal 4, and I equal 5. 1 minus 3 is minus 2, and 3 squared is 9. So 9 minus 2 is 7. So we get 7 for here. And 4, 1 minus 4 is minus 3. And then 4 squared is 16. So this is 13. And 5. 1 minus 5 is minus 4. 5 squared is 25. So this is 21. And they add up to be so this total comes out to be 49. Here, 44/22, that's half as much, half as much, half as much. So we could say this is 44, then 44 times a half, and then 44 times a half is 22 times another half, which is 11. And then the next one would be 5.5, and it would be 2.75, and then half of that is that. So 1, 2, 3, 4, 5, 6 terms. And the next one would be 44 times a half makes the 11 times another half. So that's 1/2 to the 1/3 power would make the 5.5. Fourth power would make this, and the fifth power would make this. So we got to add up I starting at 0 because there's no halves times this one, going to 5, 0, 1, 2, 3, 4, 5, or 6 terms, and it's 44 times 1/2 to the I. Or you could have said 44 over 2 to the I, because that would make it more and more 2's divided in there. Or you could have it go 1 to 6 and go I minus 1 for a power, or do I equal 1 to 6 of 88 divided by 2I. And so when I is 1, that would make 44. When I is 2, it'd be 44 divided by 4, which is 22, etc. So those are possible answers, and there are others.